The most common way that chemists express or represent chemical reactions is through chemical equations. And here's an example on this slide of a chemical equation of the reaction of oxygen with methane, which is based on the reaction we looked at earlier with the use of models. Chemical equations express the reactants and the products as their chemical formula. There's the arrow here that separates the reactants from the products, and there is a plus sign between chemicals on either side of the arrow. Now, for a chemical equation to be useful, it needs to be balanced. And what we mean by balanced is there are the same number of atoms of each element on both sides of the arrow. So the way that we count atoms is we multiply the number in front of the chemical formula, which tells us how many molecules there are, and that is known as a coefficient. If a number is not expressly written, then the coefficient is 1. So if we look at this chemical equation, which is balanced, there's no number here in front of methane, so that means 1. So 1 times 1, I have 1 carbon atom, 1 times 4, 4 hydrogen atoms. Oxygen has a coefficient of 2. 2 times 2 is a total of 4 oxygen atoms. So on my reactant side, I have 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. If this equation is balanced, I'll have the same number of atoms of each element on the product side. No coefficient is written in front of carbon dioxide, so I have 1 times 1 carbon atom. I have 1 times 2 oxygen atoms. I have a coefficient of 2 in front of the water. So 2 times 2 means I have 4 hydrogen atoms, and 2 times 1 means I have 2 oxygen atoms from my water. So on my product side, I have 1 carbon atom, like my reactant side. I have 4 hydrogen atoms, like my reactant side. And I have 2 plus 2, which is 4 oxygen atoms, like my reactant side. So this equation is balanced. To balance a chemical equation, you have to make sure that the number of atoms of each type of element are the same on both sides. The way that you do that is you have to count the atoms on each side by multiplying the coefficient times the subscript for that atom. And if a given atom of an element occurs in more than one chemical, like oxygen does on the product side here, you have to add the atoms together. To balance it, you change the coefficient in front of the chemical formula. You have the authority to change that coefficient to whatever value you need to change it to so that the number of atoms of each element is the same on each side of the arrow. When you balance a chemical equation, you never ever change the subscript. You're not allowed to do that because that just changes the chemical and that will not represent the chemical reaction correctly. If you change the chemicals, you can only change the number of molecules that are reacting by changing the coefficient.